So today we're going to continue our study of volume of prisms. Yesterday we talked about rectangular prisms, what you think of as a traditional box. Today we're going to move on to triangular prisms. Now, I want to take a step back for a second to when we did area. So if I wanted to find the area of this rectangle, I would do length times width. Now, if you remember when I cut it in half and made a triangle, that would be 1/2 times length times width, or sometimes we change it and call it 1/2 times base times height, because I literally cut it in half, right? So if that's length times width, and this is 1/2 times length times width, when we apply a third dimension, yesterday we talked about volume as being length times width times height. So what do you think a triangular prism is going to be? 1/2 times length times width times height. All right. The other way that we talked about this yesterday is we did big B. So rather than doing the length times width, we knew the area of this rectangle and then just multiplied by the height. Similarly today, you have big BH. So if you know the area of this triangle already, you can just multiply it by its height. All right. So use some of the things that you already know. It actually makes today's lesson a whole lot easier. All right. I am on page 748 in your textbook if you want to follow along with me. I'm going to zoom in just a little bit. So up at the top here, they give us the one formula of volume equals big BH, which is exactly the formula we learned yesterday. The only thing that's going to change is the formula used to find the base. Yesterday we were talking about rectangles, which is length times width. Today we're talking about triangles, which is 1/2 length times width. Okay, times the height times how much we actually stack it up is the same. All right. Now, when we go to look at some of the measurements, let's go down to example 1. Okay, there's numbers all over this problem. Take a minute to think, trace it out with a pencil if you need to. Where is the triangle? The triangle is the important shape on this, right? There's one triangular base, and there's the other triangular base. So forget everything else for a minute, and let's think about how to find area of a triangle. Well, I need base and I need height. And I know those two things are always going to be perpendicular. So let me look for this little rectangle, this little 90-degree angle box. Okay, the sides that come off of it are right here and right here. So I would say that those are my base and height, or length and width if you're still using that formula. Okay, this isn't going to do much because this is the other side of that triangle. It's extra information. But what I do need for the volume is how far apart are these two bases? That's this other number. Okay, so the triangle itself would be 1/2 times 8 times 10. And then I'm going to stack those 13 high. There's your formula. Now, if you wanted to follow big BH, you do what they did over here. 1/2 times 8 times 10, that's your big B, or area of the base. And then times the height, which looks exactly like what I wrote. It just used parentheses instead of an extra dot. Same thing, whatever you prefer. Our units will still be cubed, meters cubed or cubic meters. Two ways you can do this. You can multiply the whole numbers first, do 8 times 10 times 13, and divide that whole thing in half. Or you could do the half here and get half of 8 is 4, and then do 4 times 10 times 13. Completely up to you. You could even do 80 cut in half and then times 13 if you're truly following the order of operations. Any way you do that, you should get the same answer of 520. Okay, let's go down to A and B. I really want to work on finding the measurements that you need. If you have to take your pencil or take a colored crayon or something and trace the triangles, do it. When you're first starting, these can be very, very tricky. Look at all those numbers. I don't know which ones I need. Let's try it. So here's a triangle. And since we're studying triangular prisms, that's what you need. There's a triangle on the bottom here. Okay, I need length and width, or sometimes we call it base and height. So when I think about the triangle, I need a right angle. There it is. So I'm going to need 4. And the thing that's perpendicular to it is 3.5. That's my triangle. Then I need to know how far apart are these two triangles. It looks like it's the 7. Right? So my formula, I like the 1/2 length, width, height. because everybody just knows it. It's very similar to the other one, but it's still specific enough. If you did BH, big BH, that can get confusing. Okay, so 1/2 times 4 times 7 times 3.5. I'm going to use x's because I don't want to be confused. Okay, but then you're going to say, hey, wait a minute, I thought 7 was the height. Well, it is, but you know commutative property, I'm allowed to switch these around. So if I did times 3.5 times 7, or if I do times 7 times 3.5, the order will not make a difference because it's straight multiplication. Okay, so then I would multiply these across. I'm going to do half of 4 first because it's 2. And then I'm going to do 2 times 3.5 because I can get rid of that decimal. And I know that 3.5 doubled is 7. And then 7 times 7 is 49. So without a calculator, my friends, I know that the area is 49 cubic meters. All right, let's look at B. Here is a triangle, and here is a triangle. They form the basis of my prism. I know that I need perpendicular, so I'm going to do 7 and 8, right? And then how far apart are these two triangles? 10. Let's put those problems up. So volume of a triangular prism, 1/2 times length times width times height. But there's only 3 numbers in the problem. I know, it's good to talk yourself through it. Getting good habits. All right, 1/2 times 8 times 7 times 10. I'm going to cut this in half and get 4. Half of 8 is 4. 4 times 7 is 28. 28 times 10 is 280 cubic yards. If you've ever gotten mulch or dirt delivered to your house or even taken away if you were building a pool or something, a lot of times they talk about cubic yards. That's the measurement that we use. Okay, one more. This one only gives us the 3. So we'll plop those numbers in real easy. They're talking about a skateboard ramp. That looks a little steep to me, but hey, we'll go with it. So formula, volume equals 1/2 times length times width times height. They're going to use big BH. Our triangle is 10 and 7 because there's a little right angle box. And then spread apart 4 feet. So it's a 4-foot wide ramp. We'll do 1/2 times 10 times 7 times 4. This will give me 5. 5 times 4 is 20. 20 times 7, 2 times 7 is 14 with a 0. There we go, 140 cubic feet, which is exactly what they had. If you needed to build it out of concrete or you needed so much dirt that you were going to pack down very tightly to support the boards perhaps, that's how much you would need. All right, so if you prefer this big BH, fine. I'd at least like you to be familiar with it, but most of us are going to default to the 1/2 length width height because it's so similar to what we know for rectangles, length width height or 1/2 length